All right, so in this video, we're going to be walking through some examples of how to simplify square roots. Now, the general idea is that we can find common factors within a square root that might themselves be perfect squares, and then we can apply the square root to the two separate products. So let's look at our first example, the square root of 125. Now, the square root of 125 has factors of 25 and 5. And so what we can do is we can actually split this into two square roots. We can split this into the square root of 25 times the square root of 5. And then we can apply the square root to the perfect square factor. That'll give us 5 for the square root of 25. And then it'll leave the 5 that's still under the radical, that is not a perfect square, still under the radical. And so instead of the square root of 125, we have 5 radical 5. Now, this is an important process in case we want to cancel factors, reduce in a ratio for something, for example, or if we want to add other square roots to it. If we can find the reduced form with the smallest non-perfect squares left under the radical, then we might have a chance of combining like terms. Whereas if we're only looking for other multiples of 125, we might have more difficulty. Now, sometimes you can do this through an iterative process. Maybe you can't think of any perfect squares that go into 96 that are big. We could do this in one step. But what you can do is you can do this into several steps. So 96 is an even number. So we know it divides by 2, but does it divide by 4? Well, it turns out yes. So this is 4 times 24. Great. So I can take the square root of the 4, and then I have at least a simpler expression left behind. 2 square root of 24. Okay, but what about 24? 24 also has 4 as a square factor. So I can rewrite this as 4 and 6. And so I have my 2 and my square root of 4 and my square root of 6. Now 6 has factors of 2 and 3. Neither one of them are squares. 6 is itself not a perfect square. So the square root of 6 is going to stay there, but I can simplify my square root of 4 and get 2 times 2 times the square root of 6, or 4 square root of 6. Now, it is certainly possible to do this in one step if you recognize that 96 is divisible by 16. So it turns out that 96 is 16 times 6, and therefore I could have the square root of 16 and the square root of 6 directly and get 4 square root of 6. But again, if I don't know that 16 is a perfect square factor of 96, that's fine. I just need to find one perfect square factor of 6, and then I can reduce the problem, and then I can keep going until I get down to a point where I can't go any further. Now we can do the same thing for very large numbers. For very large numbers like the square root of 38888. Now, this is not a perfect square that I've memorized, so I have no idea what the best perfect square factors are. I see that it is definitely even. So I can sort of work my way down as I did in my previous example. Is this divisible by 4? 38888 divided by 4. I actually, because of the 3/8 at the end, I'm pretty sure this is divisible by 8, but that doesn't really help me because 8 is not a perfect square. So I'm going to divide it by 4, and that is going to give me 4 times, and according to my calculator, 972. And so that is going to get me 2, and the square root of 4 is 2, and 972. Well, clearly 972, I also think is divisible by 4 because 72 is divisible by 4. So I'm going to try to divide this by 4 again. 972 divided by 4 is 243. Super. So the square root of 4 is another 2. And now I have the square root of 243. Okay, so what about 243? Well, 243, I'm pretty sure, is a power of 3 something. I think it's 3 to the 5th. So I know I can take a 9 out of that. So I'm going to rewrite this as 4, 2 times 2, and then 9 times, well, 243 divided by 9 is 27. And that's square root of 9 is going to give me a 3. And then I can do this again. 9 times 3. And so I'm going to get another 3 to come out. And so that's going to leave me with 36 times the square root of 3. So again, I mean, it's great if you can find a large perfect square factor. And there's nothing wrong with like going through your list of perfect square factors and trying to try a bunch of them to see what's the biggest one that you can take out of there. Absolutely nothing wrong with that, but you don't have to proceed that way. You can just start with, what do I know I can divide out of this, and simplifying the problem and simplifying the problem until you get to a point where you are as simplified as you can get. And sometimes I find that being methodical can be really helpful in terms of, making sure that you've done this process and they are not just like, you're not just leaving it because you think that there's nothing that can go into this.